Hi guys, it's the 18th of August 2014 and we're back here with the Higher Truth channel's response to the video that I did a couple of days ago. I'm going to address each point as best as I can and return this feedback. So they responded by saying, what part of the record warm oceans do you think people will not get? ? Apparently all of it. Also, a million times we've shown current sunspots, not just the trend. And they state, you have not shown anyone today's sunspots total. Why is that? So we're going to do that right now. So we're looking for today's sunspot numbers, and we're over here at CILSO, which is the World Data Centre for the Production, Preservation and Dissemination of International Sunspots number. We've got the dates down there. We can see on the August the 14th it was at 59, August the 15th 74, the 16th was 77, the 17th was 82, and August the 18th was 75. And if we just look, we could look at this graph here. We can see the trend over the recent solar cycle so far, and we can see that it has peaked around about here at its highest, where it was about 105 maybe, and we can see that it is forecast to be dropping. Now there is another website we can check, but before we do, let's just have a look at this graph as well. So we can see the estimated daily sunspot numbers are and have been over the month relatively well. At its lowest on the 10th it was around about 42, which has gone up a little bit to 80, say 81 just about, and then back down to today's number of 75. What I want to do is just have a look at another graph over a longer period of time, so we can see how that plays then with the recent sunspots and solar cycles, and we can see where we are with regards to that. So here we are, it's the 8th 2014, and we're at solar cycle 24, which is this cycle here. That's solar cycle 23. We can see that from what we've just deduced, there is 75 sunspots visible on the sun's surface. So 10, 20, 30, just around midway of that, we come across there. So it's crept up slightly, but what we've got to realise here is that we're in 2014, and the sun has gone through its solar maximum, and it is on its downward incline now. So it's less likely for this solar cycle to produce more than what it did at the maximum point. So we're looking at a trend now that could be dropping off over the next year or so. Well, if we look at Livingston's and Penn graph and just compare it with what we're looking at and the trend we're looking at, we'll see that according to their graph, the sunspots will drop off because the surface temperature of the sun is going to increase in temperature, and that will disfavour magnetic ability for sunspots to form after that point. But we can see that we're already through the we're already through the solar maximum, and there is a big difference between the amount of sunspots during that period of time where it peaked compared to, if we look at the solar cycle 23, we can see that it was around, at its peak, 168, say 170, where at this peak we're just peaking over 100. So there is 60 odd sunspots during each maximum, a difference. And we're going to have a quick look at Williamson and Penn's report just to rebut that. And again, as the chart shows, a field strength of 1500 gauss, there will be no photospheric darkening observed, and that is where irradiance is manufactured in the photosphere, somewhere in between 10,000 Kelvin and 4,000 Kelvin. At the top of the photosphere, somewhere in between there is the manufacturing plant of irradiance, or radiation in the form of infrared heat, and it's that point where the gauze starts to drop. It increases the ability for them hydrogen ions to grab the leaving radiation and therefore trap it, so we get less radiation being emitted from the photosphere. So what we really want to look for is something that shows us the same trend over the last two solar cycles with regards to a reduction in irradiance. So that's what we'll do next. So looking at the comparisons with sunspots, irradiance and solar flare index, we can see that they are all pretty much on the same line. Now, you did mention the daily irradiance over the last two solar cycles, so even if we compare that, the daily radiance in the yellow, we can see that there is a lot more peaks in solar cycle 23 over 1367. There is more peaks over in solar cycle 23 than there is in solar cycle 24, so the irradiance has dropped, and it is noticeable anyhow. So also, if we look at the the line of irradiance, the black line, we can see that with regards to sunspot observations, which is the blue, so the black and the blue is what we're looking at, they are very well in form with each other. But I think your graph shows it a little bit better than this, which we'll have a quick look at. Again, you can see that there are three peaks on the irradiance and 3 peaks on the sunspots, and the troughs are in line with each other. I wouldn't use a daily irradiance as a gauge for a bigger picture of what's going on. I'd want more calculations over a longer period of time, and I think it brings out the trend, because you couldn't work out the daily irradiance pattern from just a little section if we just looked at those, say 2 months worth of irradiance, and you probably wouldn't see the pattern if we just looked at 2 months of sunspots. It's through looking over, say, as you have in here, 28 years, that you bring out the trend, and it's the trend of these sine waves that we're looking for. And even in the irradiance here, if we look at this area here, we can see that it matches sunspots very closely. The point of this is that irradiance is dropping with the amount of sunspots, and it's what that leads to. Now, I think the only thing I need to do here is show you a temperature graph over a period of time, and we can go back to the maunder minimum and back to the Dalton minimum, where we see the temperatures drop, and we can also see a correlation between sunspot numbers dropping at those points as well. And all we've got to do with that information is forecast the next few years of sunspots, what's likely to happen with them, using data that we've gained from Livingston and Penn with regards to the magnetic gauge dropping on the sun's surface, and when that is likely to take place, and also we know that when that takes place, that the photosphere shuts down, and irradiance goes down from that point on as well, as sunspots do, as the Livingston and Penn mainly talks about. So just to quote you again, on the Eye to Truth channel, you state, you try to prove irradiance will fall and haven't even compared what is happening today with low sunspots. That's kind of weird, don't you think? All I ask is that you look at the sunspots today and compare them with irradiance today, and you'll see, I suppose, they're half of what they were last solar cycle, less than 10 today, and you laugh out loud. Well, I've just demonstrated that that's incorrect. We've looked at irradiance, we've looked at sunspot numbers, and you can see that as sunspot numbers fall, so does irradiance. You've seen the data that proves that. So again, all I think I need to do here, just to give further proof to substantiate what we've already discussed, is show the temperature during those times where low sunspot numbers were. And we can see during the Dalton minimum and the maunder minimum that at both times the temperatures dropped, and not only did the temperatures drop, that sunspots dropped and also irradiance dropped. So here we are on a 300-year thermometer record of central England, and you're looking at the temperature in centigrade, and the 2 points that stand out, they've been marked at just after 1821, the Dalton minimum, and before 1701, which was the maunder minimum. Now all I need to do, I feel, to back this up, that sunspots are related to temperature changes or climate changes on the Earth which favour a cooler climate, is show you 400-year sunspot record, which you already know shows that during the maunder minimum and the Dalton minimum, those 2 periods of time, there was less sunspots, and that's exactly what I'm going to do now. So looking at both the 400-year sunspot observations and a 300-year thermometer record, we can see the 2 troughs that are clear from around 1701, which was when the sunspots began to pick up. But before that, we had the maunder minimum. It was described as the little ice age, and we can see on the 300-year thermometer record that the temperature was low at that period of time. It corresponds with sunspots very nicely, and also irradiance, as we've shown on the other graphs. We can see that it peaks, begins to pick back up, the sunspot numbers as does the temperature, from this period here to here, and that is represented by an increase in sunspots. Let me just see if I can get a better pointer so that I can show you a bit clearer. So from the 1700s to the beginning of the Dalton minimum, where it peaks again, in this trough, the temperature goes down again at the Dalton minimum. But from this period here, just before the Dalton minimum, and from the end of the little ice age or the maunder minimum, we can see the temperature increased, and that's that peak here. And we can see in centigrade on the left hand column that the temperature has increased up until this section here. So this increase in sunspots that we're looking at corresponds to an increase in temperature on the 300-year thermometer record. We can see that it goes into a trough again at the Dalton minimum from the 1800s to say 1830s. So we want to be seeing a peak in the 1830s in the temperature, and that's what we're seeing from that point on. Then there's a little trough again here, which would be during the 1900s. We can see the sunspots are low at that period of time, and then from 1940s to the 1950s, we can see there is an increase in temperature again. So from 1940s to the 1950s, we'd see the temperature increasing, and it does right up until the 80s. And the problem is with the 300-year thermometer record is it doesn't show us what's happened from that point, because as we can see on the 400-year sunspot observations, that from the 1950s it begins to reduce. Now, with regards to solar radiation, it's just output of the sun, and I want to show you what NASA have been monitoring over the last 50 years with regards to solar wind, and also with relations to that. So I think I've covered my ground very well. I've argued the argument's been argued very elegantly, I think, and it's been supported with facts that state quite clearly temperature, sunspots and irradiance all fall when sunspots fall, and you've seen that clearly on that other graph as well. So there is no discrepancy in that fact. You know, irradiance is following sunspot numbers. If sunspot numbers drop, so does the irradiance drop. And if the output of irradiance, which is radiation or heat, if that drops, we see it reflected in a 300-year thermometer record. You know, that is quite clear. There's no arguing there. That, you know, that is the facts. The data is there to support it, and the data goes back, you know, 400 years, and we can you know, draw conclusions from different sections of the data with regards to temperature. And therefore, you know, when we start to see sunspots dropping, we know that irradiance is going to drop and follow it, and we've seen that on the irradiance chart and sunspot chart. And we can also see that when the irradiance drops, temperature drops, and that is why we say we're heading into a more cooler period, which could mimic at least the Little Ice Age. Now, there are a lot of scientists stating that this is going to be a lot worse than the Little Ice Age, and I, for one, agree with that. And the reason why I agree with that is because back in the 1650s we didn't have a magnetic reversal taking place, and we have at this point in time. So that means the magnetosphere is going to be weakening on the Earth, as well as you know, sunspots dropping on the sun. So, just to briefly summarise then, the solar climate relationship, right? We have a lower magnetic field strength on the sun, right? That reduces the sunspots. It also reduces the production of solar radiance in the photosphere. This in turn produces less solar wind, which shrinks the heliosphere. It allows more galactic rays or cosmic rays to come inbound from our galaxy, and these act as this generates more lower level cloud formation. The reason why it does that is because these particles are perfect platforms for seeding the clouds, so we get more cloud formation, and more sunlight therefore is reflected back into space, because it is basically just bouncing back off you know, the cloud formation. The other thing is that cloud formation contains a lot of H2O. Most people know that, but it's a tri-molecule, and when it receives cosmic rays, it jostles and vibrates, and therefore it does knock it back out. And the other thing is, with regards to CO2, H2O is sitting higher in the cloud formation than CO2, so the interaction is with the water molecule, the H2O first. What else? You know, and as a result of you know, more lower level cloud formation and that more sunlight being reflected out into space, the Earth becomes cooler. And again, with you know, the solar wind losses that we've experienced over the last 50 years, it states here, this is from NASA, the average pressure of the solar wind has dropped more than 20% since the mid-1990s, says David McCombs of the Southwest Research Institute in San Antonio, Texas. This is the weakest it's been since we began monitoring the solar wind almost 50 years ago. Problem is with that is, when you have a 20% reduction in solar wind, you have a 20% reduction in the heliosphere's strength, so more cosmic particles can come in, and as we've seen in the flowchart, that affects the amount of lower level cloud formations with regards to providing a perfect platform for these water droplets to condense onto, so that the cosmic rays actually act as a seeding effect, and that produces more water vapour in the atmosphere, more clouds, and as a result of that we get more sunlight and heat in the form of radiation just bouncing straight off our atmosphere, because it's interacting first of all with the H2O molecule, which is a greenhouse gas anyhow, and it's going to interact before it interacts with the CO2 molecule. What else was there? Again, if we look at the space environment overview, we can see on the top of this here, just try and get a better pointer again. On the top we've got the last 3 solar cycles, solar cycle 24, 23 and 22, but when we start getting weaker solar cycles with less numbers, the cosmic rays on the next chart down starts to increase every time, and what we can see that just before solar cycle 24 starts, a very large influx of cosmic rays. Remember, it's those cosmic rays that cause cloud seeding to take place, and more cloud leads to positive feedback, and therefore we end up inevitably with a shielding effect from the inbound solar radiation, and it's probably twice as worse, because the sun's output of solar radiation is dropping off with sunspot numbers, and again that is to do with the surface temperature increase on the surface of the sun, which is diminishing the ability for sunspots to form. To quote you again, you state that you know and I know what the lower magnetic field means. It's pretty basic. 3 times more irradiance getting through than through those shields. Well, that's not the case, because I've demonstrated that. You've seen the irradiance, you've seen that it's less, and you also see that it follows a trend with the sunspots, and when the irradiance drops, as a result of sunspots or low solar production of irradiance, we have a decrease in temperature. So we're not seeing more irradiance because of a weaker magnetic field at this point. It isn't showing up in the data that is being collected. So I can't agree with you on that. I've also checked that chart on the right with other total solar irradiances by other equipment, and we can see, if we look at the charts on the left, or the columns on the left hand side measuring the irradiance in watts per square meter, if we look that all 3 of these peaks do peak over 367, 1367, and again there's 1367. We can see that the 3 peaks do go off into 1368, albeit very few, but we can see that there is more peaks on the left hand chart, peaking into 1368 watts per square meter. The point is, if we check 1990 with the peak of the sine wave and compare it with 1990 on the right hand side graph, we can see that both charts are measuring around about the same total solar radiance, and we can see that there is less solar irradiance in the latter solar cycle on that graph, and that is consistent with the chart on the left as well. Again, to quote you, you say, if sunspots mirror irradiance, why is irradiance still way above solar forcing line and sunspots are less than 10 today? Gulp. Well, as I've already showed at the beginning of this video, sunspots are at 74 on the 18th of August. On the 17th of August there was 80, and on the 16th of August 77, 15th of August 74, and the 14th of August 59. So that is, there hasn't been in the last 1, 2, 3, 4, 5 days sunspots anywhere near less than 10, as you state in your comment there. And then you go on to say, you say it's going to decrease, but we say, hey, look at it, it hasn't decreased. That's a huge difference between what is versus what we think may be. And finally, you ask, how does methane lend itself to cooling. It doesn't. Methane is running away. Well, you talk about methane bubbling up like champagne in Norway, I believe it was, in that statement. But the fact is, if we get more methane in the atmosphere, then it's going to combine with the oxygen that's already in the atmosphere, and two oxygens of molecule and a methane molecule will react to form two water molecules and one carbon dioxide molecule. And as we'll put in more of both carbon dioxide and H2O, as you both know, both are greenhouse gases, and with there already being a very large positive feedback in the atmosphere already with water, that is just going to compound with the water already up there, and eventually, as we've stated in the flowchart earlier on in this video, it is going to lead to further irradiance being bounced back out into space. So that's what my take is on if we are getting more methane go up into the atmosphere, it's simply going to form more water and more carbon dioxide. Again, you talk about record ocean temperatures, but if we look at the monthly mean global surface temperatures, which include land and ocean, we can see that even if we go back from 1996 to say 2008, there has only been an increase in temperature by 0.5 degrees. Yes, it is significant, but it's not as if the oceans have just started to boil over. But the point is, from 2008 to the present time, 2014, there is very little in an increase in temperature, and maybe that is because we are now going to start seeing those ocean temperatures and those surface land temperatures begin to fall, and it will probably fit in line with the sunspot numbers, the irradiance numbers and the temperature numbers, as we expect and as we have demonstrated throughout this video, that all three of those anomalies follow suit with each other. I want to say thank you to the Higher Truth channel for giving us some feedback on the video that we did the other day with regards to the fact of whether the Earth was going to continue getting hotter, or whether it was going to continue getting colder and possibly go through a maunder minimum or ice age. I have to say, with the evidence that we've looked at, and I've tried to be unbiased in the way we examine the evidence, but we have found to the contrary, quite the opposite as to what you're suggesting, that global warming is going to continue. We've looked at daily sunspots, we've looked at irradiance, we've looked at 300 years of global temperatures, we've looked at 400 years of sunspots, and we've looked at various charts, and we've also looked at what the possible causes are with regards to low solar pressure and the deflating of the heliosphere, bringing in more cosmic particles, and the positive feedbacks that leads to. I have to say, there is nothing in what we have looked at today to substantiate your claim that this globe is going to get hotter and we're going to experience more global warming. Even looking at the global surface mean temperature of the Earth, with regards to oceans and land, we see that from 2008 there doesn't seem to be any increase by any large amount over a period since 2008 to the present day, 2014. We do see an increase of around about 0.5 degrees Celsius from 96 to 2008, but like I say, the line appears to smooth out at that point and not increase or decrease, and I suggest that could be because it's about to swing in the cooler, favouring a cooler surface or GMST. You know, what else is there to say? You know, guys, you know, we've always been on the side in favour of a global cooling, and it certainly looks like that. I mean, we've gone through quite a bit of data in this video. It's took me the best part of the day, and I can understand, you know, Higher Truth Channel, when they start going through the data, you know, it does become time consuming, but I think you have to analyse it unbiasedly, and you have to report the truth on it, and that is what I've tried to do to the best of my ability. It still appears to me as though we are going to, if the trend continues, quote, if the trend continues, go towards possibly what was witnessed back in the 1650s, and that was a mini ice age, if not a full ice age. The only thing we can do is just progressively follow the data which we're examining today in this video, and you know, to see if that will be the case. And you know, with that, guys, I apologise for the length of time I've taken in this video. I want to thank Higher Truth Channel for their feedback, and if they want to give some more feedback on this, you know, then, you know, I welcome that as well. But the purpose of doing this video is to not confuse people. You know, we can't have people saying that global warming is going to continue, but it's not because of CO2, and we can't have at the same time other people saying that no, it's going to get cooler. And you know, what we have to do is examine the evidence critically and unbiasedly, and report the truth as you see it. Otherwise, we're just going to confuse people, you know, and that isn't going to help anyone. What we're trying to do, as you have already said here, you know, our common ground is telling people to be prepared. So, you know, that's what we should continue to do, and you know, we'll just see how this plays out. If the trend continues, it will go colder, the climate will follow, as will the irradiance. So with that, guys, whew, lot of data. As usual, be safe, be prepared, and I'll say bye for now.